Okay. Yesterday we have done up to which point? We are doing. We have done up to multiple. If okay. Then there is one more program. I wish to continue from there. So you do one thing. Just try to do this. Get a program. Let us solve this. Write a program to find the greatest of three numbers. Greatest of three numbers. We have done this with multiple if. There is one more thing in if. We have three forms of if, right? If has three forms. What is that? Simple if. Second one, multiple if. We have worked with all this. And third one, nested if. Okay. What is nested if here? We have tried a program with nested if. Greatest of three numbers. Let's rewrite with nested if. Okay. So now nested if. What is this? An if within another if is known as nested if. And the syntax look like this. What is that syntax here? If condition one, opening brace. Again inside this you have one more if. Again inside that you can have one more if. It continues like that. Again inside this one more if. Condition two. Write down statements. So this is how it goes. Again inside that you can put one more. You can put one more like that. So here, how this works is if condition one is true, then you come to condition two. Okay. If first one is true, then only come to second one. If outer if is true, then only get into inside inner if. Okay. So that's how you have to work. If outer if is false, then you cannot execute condition. Okay, following it. Condition two is executed only if condition one is executed. That's how it works. Right? So this is how we have done multiple if yesterday. Rewrite the same program with the nested if. The same program you rewrite it with the nested if. Right now, I told you, right? We have to keep practicing it. Then after this, we'll switch to if else. Okay. For 2 minutes, guys. I'll be back. Sorry guys. Let's continue. So we were talking about this one, right? Nested if, how to use this. So when you talk about nested if, just now I told you how it works. So it is an if inside if. If outer condition is true, then only you come to inner condition. Right? That is true, then you get inside this if here. Okay, that's how it works. Let us test it now. Yesterday we wrote this program. This is the one we wrote yesterday. Let us rewrite the same program for nested if here. Okay, this is multiple if. Okay, next let us see this. How do you rewrite it? Rewrite with multiple if. So here it's simple. We have to keep if inside if here. This time when you are finding the greatest of three numbers, you have used this AND operator. To combine conditions, we have applied AND operator. But you can also do the same without AND operator. You can split it into two conditions like this, x greater than y. That is one thing. And then you have to push the condition to inside if x greater than z, like this. Now here you can see here the same program without any AND. Now I am able to do it. Can you see that? I'm not using any logical operator here to combine multiple conditions. So we can also do like this. Okay. Now what happens here? This is only just to understand how nested if works. Okay. Not every time we need to do like this. It depends on the logic and the problem. Like whether you to combine conditions in single if or whether to push into multiple if. Sorry, nested if. Depends on the problem and requirement. So, but understanding how it works is important. Now, if you see here, if here I have split it into two conditions. In the first condition, I said if this is true, then go to this. And you know, if x should be bigger than y and z, what is that you have to do? You have to compare x with y and x with z. Means the outer if condition should be true and inner if condition should be true. Then only you can say x is bigger, right? So even if the first condition is true and second is false, then there is no use because you don't get this out. Sprint is not executed. Understood? So same thing you have to do it for remaining two also. You need three nested if blocks. One for validating x, one for validating y, one for validating z. So how do you validate y now? So y greater than x and y greater than z. Similarly, z greater than x and z greater than y, like this. So this is how you have to find the greatest of three numbers by using which one? By using nested if. All of you are good here. Do you understand this, folks? Is it clear for all of you? Are you there with me? Guys, are you following? Okay. Look, what do you do right now? Just run this program. Now, these were our values here. You look at it. We have how many values here? Three different values, x, y, and z here. Now, right click. Excuse me. Run as Scala. Okay. Now you got it. What is that we get here? We got x is big here. Can you see that? Because 150 is bigger than both. Similarly, you can try for y. Okay, I give 500. Check it for y. Run as scale application. Similarly, run it for z. Run as, okay, here give it as 1200. Okay. Okay. And save it whenever you make changes. You know why everywhere you are getting x is big, because we have to make some change in the prints. And print don't know that what we are writing. Okay, it will print whatever you declare as string, and it's your responsibility to make sure to print meaningful statements. Okay, so again, right click, say run as scale application. Now z is big. Can you see this? It is saying z is big. Suppose if I give 500, now you know y is bigger. Then right click and say run as scale application. It said y is bigger. Got it, right? So this is the idea about the basic understanding of different forms of if here, and we have discussed every fundamental thing. All of you are good now. Is it good for all of you, or anybody has any questions on this? Can I get an yes from? Yeah, yeah, yeah. All of you? Yes, no. You want me to repeat? I told you right. If you have any issue, just tell me to repeat it. Okay. If you don't understand, you can ask me always. Next one. So this is about this next one. If else, we'll finish off it. Okay, we'll finish off it. If else, and then we'll switch to the loops. And then there are very good logics we can implement with the loops. See, I am trying to build your logical thing. Okay, without having proper logic foundation. If you want to master anything, then it's actually, it is something what we call, you are trying to build something without pillars. Now next one, if else. See, if now you are comfortable with if, working with if else is so simple for us. It looks like this, something like this. Because if else is enhancement of if. It is not substitute to if. It is a extension of if, extending if. That is what if else is. What it does. Same. See, if else in sense that if thing doesn't change, whatever we have discussed about if so far, it is same. So if we are adding else part, means it looks like this. If condition is true. And one more thing is condition is always checked by if only. That's why if is called a conditional statement. Else don't have a condition, sir. Else is another block followed by if. That's all. Understood? But who will check the condition? Always condition is checked by if. So if condition is true, if block is executed, till this point. Suppose if condition is false, else if condition is false, what happens? Else block is executed. Which block is executed? Else block is executed. Following. This is what happens. And we learned this kind of thing in the school days itself, isn't it? So if it is something do this, otherwise do that, something like that, same thing here. And this is very simple actually. The syntax look like this. What is that? If condition, you have to pass condition to if. I told you just now. We have to always pass condition to if itself, sir. Else, opening braces, then closing statements. Okay. So now, what is the execution flow of if else here? If condition is true, then execute the if block. Otherwise, execute if condition is false, go to else block. That is it. Okay. Now let us just do a couple of programs on if else. If this is true, execute this block and skip this. Again, else is not execute. If condition is false, then go to else block. Next, what do you do right now? Solve these three programs again. Write a program to find with the if else. Write a program to check to find greatest of two numbers with if else. Again, even or not. Try these two programs. Write a program to find whether a number is even or not. Using if else. Try with the even or not. With if else. Try these two programs. Then I will switch to else if ladder. That will close our which one? Close our decision making statement. Then we can switch to loops. All of you just complete these two programs. It will hardly take 1 or 2 minutes. Then after that, we will discuss multiple if else also, but that is fine, not an issue. And then we need to focus on else if ladder. Is it finished, guys? Okay, I'm solving this. Observe this. It's a simple one. There is nothing difficult here. Just remove one variable. Otherwise, you can comment it. Then what do you do right now? I don't need these many ifs here. Just one if is enough for me. If x greater than y, then what is that? X is bigger, isn't it? So what do you have to say? Println of just write down x is big. That is one thing. Okay. Plus x. This is this is supported still. I told you right. 2.12 or little later versions, but from 2.13 we have to use string interpolation. You have to concatenate with dollar. You have to use a dollar symbol there. Okay, don't forget that. Similarly, else simply there is nothing to do here. You just need to add. Don't put condition with the else. Okay, if anybody is new to programming, don't put a condition with the else part. And you can say here y is big and print y. Save it. Now run this program. Obviously, 150 is less than 500, then you get y is big here. Suppose if you give this as 1500, you get what? X is bigger. Okay, that's fine. Ready for next program? So even or not, what do you do here? Just one variable is enough. So here, if right, how to check whether a number is even or not? If it is divisible by 2 and remainder equal to 0, then x is the even. Else x is the, excuse me guys, x is odd. Right click, run as scale application. Okay, that's it guys. This is the idea about this too. Now you can try the same for odd number also. Okay, if we give something like this, and if you run this, observe this, you get x is odd here. I think most of you know this, but still, as I want to go with some order, so I'm teaching all this. Otherwise, no, we can skip all this. But the point is, if some of you are not having proper idea about these basics, again it becomes difficult for you in the future. So not to have such issues. So I am explaining each and everything. I know for some of you it might be a little boring for you because you might have already know about these things. But just have little patience so that everybody will be on the same page. That is what I am trying to do here. Now, if else is done, okay, then there is nested multiple if else as well. But multiple if else in sense, same thing you write multiple times. And when you have multiple if else, you can try to compare multiple conditions one after the another. Okay, I'm not going to talk too much on that. I'm just switching to the else if ladder. Multiple if else is nothing more than one if else, like simple if else. More than one if else, more than one if, multiple if is there, right? So here also same thing. You can have multiple if else so that you can check multiple conditions. That's all. Clear, right? So you can try with same the first two programs which I told you, right? Greatest of two numbers, even or odd, by doing same both logics in one program. You can solve it by using multiple if else. Okay. You can have many more also. That is also fine. And else if ladder. Else if ladder. This is one more very useful construct in coding. Else if ladder is simplified. It's a simplified form of multiple if. You have multiple if, right? It is an optimized form or much more efficient form of multiple if is this else if ladder. It looks like this: if condition, condition one, opening brace. Okay, statements. Else if condition two, opening brace statements, and then dot dot dot. At the end, you can add one else block as well. If you wish, you can add one more else block. But this has to come at the end. Don't put in the middle. And else never have a condition. Keep in mind. You should not put condition. Even here, else if when you say else if, after else again you can see if is there with that. Means else alone cannot check a condition. Again, if should be there. Anywhere, if you want to check a condition, if must be there. Okay, you can have one more if else if you want. Sorry, else if, sorry. You can have one more else if. Condition three. This is how it is. Now let us try to understand the execution flow. What is that? If condition 1 is true, execute this. Okay, execute that block and then skip from there itself, terminate from there. If condition 1 is true, then it will execute that if block and stop the execution there itself. And rest of the else blocks are skipped from execution. You come to condition 2 only if condition 1 is false. Okay, if this is false, if condition 1 is false, then go to condition 2. If condition 2 is false, go to condition 3. If condition 3 is false, go to condition 4. If all conditions are false, go to else block. That's how it works. Understood right now? So what do you do right now? Let us try small sample program here. Write a program. Write a program to find greatest of three numbers by using else if ladder. To find greatest of three numbers excuse me, using else if ladder. Try this program now. This is syntax. You try this. Okay. So I'm trying to show you this. So how it works? Simple. We have already done greatest of three numbers with the multiple if. The same thing we are going to solve with the else if ladder. You need three numbers here. Okay. I'm just bringing back that multiple if program. Okay. Here, if you see this, the execution flow will be like this now. The first condition you don't need to change anything here. And second condition you have to make a small change. Else if most of you would have written like this for the first time. If you are doing it for the first time, you say y greater than x and y greater than z. As this is the else if ladder, the advantage is here. It is multiple if each and every condition is validated. But if it is else if ladder, if condition 1 is true, it will execute that block and skip from there. It doesn't execute 2 or 3 or 4. Means there is an optimization here. We are just minimizing number of checks here with the else if ladder. So that is one advantage. Fine. Next one. If you look at this here, you have already compared x with y. Again, you don't need to compare y with x here. Why? Because in else if ladder, these are chain of if statements, and one if have relation to connection to another if. If it is multiple if, every if is independent if. But these are not like this. One if is connected to another if. If first if fails, then only it will come to second if. If second if fails, then only it will go to third if. Okay. But else if multiple if is not like that. Every if is an independent one. If first is fails at true or false, then still second if is executed. This is not like that. If first if is true, then second if is not executed. It will stop there itself. If it is false, then only come to second if. Okay. So you can see you can remove this actually. You don't need y greater than x. Most of us will keep that in the very beginning of writing code. But later on everybody come to this point. And third one, this condition itself is not necessary because this first if will filter x, second if will filter y, third if and if both are false, then the remaining is z only. Again, you don't need to write a condition. Following, right? So what do you do right now? Just run this and see. This time you should get y is big, isn't it? And all are having just make add something here, okay? And then x, y, z, okay? Add this point here. Right click, run as scale application. And you have y is big here because 50 is bigger. Similarly, you can test for remaining two. I know this code is perfect because we are writing it from many years, this kind of programs. No complexity in this program. Okay. This is the idea about decision making statements. Idea about which one? Decision making statements. Clear to all of you? Now I am moving to the loops actually. So we do basic logic building programs on loops. Then again, for is a bit different for you here. When you are working with for, and the most used loop here is for loop. It is an enhanced for loop or special for loop. But before that, let me quickly complete while and do while. And let us solve some very core logics which comes every time when you are working with programming. Okay, first we'll solve them. Clear, right? So what do you do right now? We are moving to the loop topic. Are you good now? All of you are good? Any questions? Any questions, sir? Is it clear to all of you? Say, can I get yes, no? Next one then. Loops. Let us switch to the loops. Loop control statements. We have three here: while, do while, and for. Do while and for loop. So what is this while loop? So if while or do while, leave about for thing because for is a bit different here in Scala. But when you talk about while and do while, it works like this. How it works? Any loop has to have these important things. Okay, it has to have an initialization. Okay, a condition, and then incrementation or decrementation. So if you want to work with while or do while, even in for also implicitly these three exist. Okay, these were the loop basics. You need to understand this better before you switch to remaining things. So what is initialization here? When you talk about initialization, it specifies where loop should start. What is that? It mentions where loop should start. Then condition. What is condition? Condition specifies how many times your loop should execute. How many times your loop should execute. Incrementation or decrementation increments a loop or it's called a step statement. Increments either increments or decrements. Okay. So what is initialization here? It specifies where loop should begin. That it specifies where loop should begin. again. Condition. How many times loop should iterate? These are very important things. This is a step statement. Without this, your loop will move to infinite loops. Why it will move to infinite loop? Because if you don't increment or decrement, the condition is never satisfied. If condition is not satisfied, your loop keep on iterating, iterating, iterating. So that's what we call infinite loop is. Understood? So that's idea about these three. For any loop, these are important. Suppose I want to print 1 to 10. Then I should declare a variable like this, somewhere a colon int equal to 1. This is initialization. Then I want to iterate up to 10. Means I need to iterate 10 times. Then I have to add a condition here. It looks like this. What is that? Some a less than or equal to 10. Means until a becomes 10 or until a is less than 10, you have to keep iterating. And loop will terminate the execution or it will stop the execution only if condition is false. Until condition is false, loop keep on iterating. Okay. So what does loop does here? Of course, these are loop fundamentals. It needs an initialization. It needs a condition. You are seeing here, and it needs a step statement as well. Then every time loop iterates, I should increment that. So loop. Then I should say a equal to a plus 1. Don't try to apply unary operators. We don't have a unary in Scala. Got it right. So what loop does generally? Loops perform a repetitive task, something it will keep doing again and again. So what does a loop does? A loop performs a repetitive task. Means it will keep doing something. It will be iterating again and again till what? Till until condition is false. So performs a repetitive task. Understood? So this is simple idea here. So anybody have confusion on this earlier? Then have a quick idea here because I see still many people struggle with the loops. Might be you can ask me, is it? You can say an exclamatory statement. Is it really true? Maybe if you don't believe or not. See, after this session, I have another session. One of my very old student. Now he is in US and he's really doing fine. He exclusively trying to improve his programming. And one thing what he told me is he is little confused with loops. He told this is my weakest area, sir. Please help me to improve my programming with loops. But he is really good with other things. But somewhere in the program, he's have some little issues. Now, every day after this session, okay, I teach him how to improve his programming. I don't mean he is bad. He is really good with the other areas. But to improve his skills, he is exclusively doing one more session. And loop is one area he wants me to focus. Understood, right? Because in the learning, what happens is in the beginning, there will be some confusion. Either you don't listen to the teacher or teacher don't teach you properly. Then there will be that confusion. Now try to avoid that. Let us be good. I can skip all this. I can finish all these fundamentals in one session, sir. Still, I am spending time because I do little complex programming. As time passes, I don't keep doing very small programs. Keep on doing different implementation kind of this thing programs. Then, if you are fundamentally not clear, it will be always little tough to follow the things. Understood? That's how my sessions will be. It's more like implementation based. So that's why I'm spending time, taking time to tell this point. So if you have issues, try to clarify this and try to be on the same page like everyone. Okay, next one. This is idea about loop basics. Now I'll start with the while loop. What is while here? Any loop performs same, sir. While or do while or for. They don't have any inhibitions. Loops are loops. Like human is human, right? Like loops are loops. They perform repetitive tasks. Okay. And again, syntax, sir. First thing is always the basic thing to understand is how syntax is and how it works. And later on, you should see how to implement a logic on that. So it performs repetitive task, no doubt about that. And the syntax look like this, sir. What is that? If and sorry, still now we have done if, right? If while condition and then statements and then step statement inside this, and then close it. This is syntax of while. What happens here? We declare a condition with while. Until this is false, it keeps on iterating. And under that, we put statements. What do? We put statements. And also, we keep step statements here. Step statement, not statements. One is enough. For one loop, one step statement is enough for us. We don't need so many step statements. Okay. So what happens here? If condition is true, then it comes inside this while. Execute the statements, execute the step statement. Then it won't skip, sir. Again, it will go back to the condition. Again, check the condition. If it is true, it again comes inside. Execute statements, execute step statements. Again, go back to condition. This happens until what? Condition is false. But the initialization part you don't do inside while, sir. Will do it on top of while, because first you should initialize, then you can come to condition. And if you should check condition, first initializing is very important. So we'll do a small program. Are you ready for this now? Write a program to find to print from here onwards. You can do very interesting programs to print numbers from 1 to 10. Can you try this code? We are planning for data science sessions, folks, soon within a couple of weeks, but it will be on weekend, only on Saturday and Sunday. So please update your friends if anybody is interested on that. Free sessions only, no money. Okay, I'm doing this program. Are you ready, guys? So now let's do it. It's a simple program. First, you should declare a loop variable. Whenever we are working with loops, one thing is important. A loop variable is very important for us. So, what do you do? Where a colon int equal to 1. So this acts as a loop variable. Okay. Then condition. What is it? While declaring, we need to declare this, specify this data type, all that. But with condition, all we don't need everything. And I declared this as var here. Can you see this? A is a var type, not val type, because we cannot modify val, but we can modify var. Okay. Now let me write a program here. So here, declare one variable, and the program is printing 1 to 10, right? So if it is 1 to 10, what do you do? Initialize this x with 1. Variable is your choice, sir. X or y or I is your choice. Okay. Next one, come to the while, and you can say x less than or equal to 10, and then opening bracer, and then println, okay, and print x here, and apply step statement x equal to x plus 1. Okay. It is showing some error. Wait a minute. I think I put it as val. 1 minute. Let me change it. Let me change to val. What should I say? X equal to x plus 1. Now, if you see, the loop has all the three things. It has initialization, where to start. It has a condition. How many times loop should iterate? It has an incrementation. It is a step statement. So what is the execution flow here? How the execution flow is? If initially the value is set to 1, 1 is set to x, then it comes to condition. Then 1 less than or equal to 10, true or false, sir? 1 is less than 10, true. It comes inside. Print this x, it becomes 1. Again increment x, it becomes 2. Again it will go back to while. Maybe you can put a debugger and check it out, sir. Put a debugger here. Okay, I put a debugger. Can you see that small pimple kind of ball there? Now go to debugging point. Okay, then you need to debugger operators. Okay, right. Okay, then Scala application debugger launcher. Okay, allow access. You need to know how to debug a code also. That is important. We can analyze without debugger also. That is also possible. Now it started with what? It started with the 1 here. And now you can see how every iteration is going to perform here. You go to run, and you can use what? We can use F5. It came inside now. You can observe carefully point by one. And then press. So what do you do right now? Again you can print. Press F5 here, step into. And again. And this keeps on, sorry. It's going into the code actually. Don't do that. Okay. You just say step into is used generally if you want to move from a function call to a function. Just set step over there. Go with F6, sir. Now it has moved to this one. Then again F6, sir. And now you have gone back to the beginning again. So after one, you can see the values here. Can you see this now? This is the value box here. If you find here, now X is 2 here. Once it goes to the top after iterating for one time, again control is moved back to the beginning of this while, and you can see the value of X is showing as 2 here. Are you seeing that? It's 2 here. Can you see this? This is actually the tracing box. And you can see the all the values, what's coming, what is the idea of each one, everything you can see here. Following, sir? Again, press F6, not F5. Don't use F5. Keep pressing F6. This is the how you have to debug. Okay. Okay. Can you see that? Again, it became 3 there. Can you see that? Again, the control moved to the top of the while. It will every time what happens is it will check a condition. If it is true, get inside, execute that, and then increment X. Again, go to the beginning of loop. Following? Is it clear for all of you? This is how to debug this. What you have to do, you should put a debugger point wherever you want at the left corner of this. Can you see there? And then go to this debugger. This is debugging option, and choose the file which you want to debug, and then press F6 to check line by line. Okay. And step into is required when you are debugging functions. If you want to move from caller to a function, then we use step into. Understood, right? So finally, what happens? Finally, you get you can see here values also getting printed every time the loop is iterated completely. After each iteration, the values get printed on console. If you observe carefully here, can you see that? This is how we should do debugging. You should learn all this, sir. As a real-time guy, what's happening? Why my Eclipse IDE taking much time to execute? Any reason for that? Sometimes your Eclipse itself is taking much time, or you are only debugging, Madhu? Only for debugging. It depends. When you do building process, it will take some time. Sometimes, as Srikanth says, it takes time to build. Yes, sometimes it will take. Don't worry. Okay. But is this fine? How to debug your code? You have to learn all these practices, sir. Tomorrow, if you want to become an efficient developer, having all this is important. Clear now? This happens until x becomes 10. Once x is 10, one last time the value of x is printed, and then x becomes 11. 11 less than or equal to 10 is false, so execution of loop is terminated. Loop is terminated, not the program. Understood, sir? Right? So that's how it is. Clear now? So I just ran it, like a normal program. I got 1 to 10 here. Understood now? So you can close all this. Now debugging is over. So we don't need all this. So I am removing all this here. Right? The festival is over. This is first program. All of you are good with this because I give a lot of programs here, lot of tasks. Okay. How many of you wish to do as to be more good with logic implementation, because that is very important at the end of the day. So you need patience. Now, first one is that. Okay. Second, write a program. Now let's start doing. Is it clear for all of you, sir? First one is clear, right? 1 to 10 is clear for all of you. Next one, write a program to print a 10 to 1. Do this to print events from 1 to 10. Even numbers, only even numbers. Don't use if. From 1 to 10 without if. Odd numbers from 1 to 10 without if. Then same programs from 1 to 10 with if. Okay, keep doing like this. So try to solve these programs. I'll take 2 minutes time and then solve one by one. I'll give, take 2 minutes and try to solve them. Then I will also solve after that. And if you have doubts, you can clarify that. Okay. Today I will upload the previous videos. I think all of you know our YouTube channel, right? Anybody is new to that? So you try to go and back up that if you wish, from Manohar Space, Learn Well Space Tech. This is our YouTube channel name. Check from there and try to upgrade yourself or get a backup. That would be helpful for all of you. Okay. Is the time 9:10, guys? Am I looking wrong time? Okay. I will just do one thing. Let me finish 10 to 1 and we'll solve remaining tomorrow. And then, okay, we switch to the do while again. We'll do few more on this, all the fundamental logic building, and then do while and then for. So now it looks like this 10 to 1 is not something difficult program. Let me show you. So here what you have to do, initialize to 10, initialize x to 10. What's your logic? You should not say less than here, you should say x greater than or equal to 1 or x greater than 1 or 0. Sorry, x greater than 0 will be fine. Then print x. And then you have to say minus x equal to x minus 1. Say minus because this is decrementation, right? When you decrement, always you have to use minus there. Okay. So this is how it works, sir. Initialize to 10 and then check a condition. So right click and then say run as a Scala application. You get 10 to 1 here. Can you see this now? So that's also initialize x to 10, change the condition and then decrement it. Clear for all of you? That's idea about 10 to 1. I hope you can do the remaining. We'll see it in tomorrow's session. Okay. We'll complete this probably, okay, this while tomorrow and then do while. Then we have to switch to for concept of scalar. Okay, guys, thank you. We'll meet tomorrow. Already it's 9:10.